Welcome to physics class. I greet you all. Today we'll be looking at the topic radioactivity. And before we go into the details of today's topic, what are we going to achieve? As students, what do you want to learn in this class? What are the goals set before you that at the end of the class you should be able to do without being assisted by the teacher? At the end of the class, students should be able to define radioactivity. Students should be able to list and explain the types of radioactivity. And students should be able to list the types of radioactive emission and their properties. Now, let's move on to the definition of radioactivity. What is radioactivity? Radioactivity can be defined as the spontaneous emission of radiation in the form of particles resulting from a nuclear reaction. How many types of radioactivity do we have? There are two types of radioactivity. They are natural radioactivity and artificial radioactivity. When does natural radioactivity occurs? Natural radioactivity occurs when a substance absorbs its energy from its surroundings, when it is buried under the soil or exposed to air. Its nucleus becomes unstable and may break up, while artificial radioactivity occurs when a non-radioactive and a radioactive element are bombarded with fast-moving particles. The nucleus becomes unstable and may also break up. Now let's move on to types of radioactive emission. There are three types of radioactive emission. We have the alpha particle, the beta particle, and gamma particle or gamma ray. We start from the first one, the alpha particle. When a substance emits an alpha particle, the atomic number will be reduced by 2, while the mass number will be reduced by 4. If you can remember very well, at the definition of radioactivity, we said it is the disintegration or spontaneous disintegration of the nucleus of an atom. And if you look at the alpha particle, it is being represented by the helium atom. And we may ask that why is it represented by helium atom? If you look at our periodic table, helium atom is number 2 on the periodic table. That is the atomic number 2, and the mass number is 4. And by definition, we said if any element is being bombarded by the alpha particle, we said the atomic number of that element will be reduced by 4, will be reduced by 2, while the mass number will be reduced by 4. So that is why the alpha particle is being represented by the helium atom. 2, they are positively charged. And 3, they are slightly deflected by magnetic field. They can be stopped by thin paper and ionized air. They have little penetrating power, and they can They can strip electrons from the atom to produce ions. Let's now look at examples. That is, we want to look at a reaction in which an element is being bombarded by an alpha particle. If you look at the examples below, we have element X with atomic number Z and mass number A. When this element is being bombarded with alpha particle, it will produce another element called Y. And in this case, the atomic number of Y will be reduced by 2. So that is why we are having Z minus 2. And the mass number of Y will be reduced by 4. And that is why we are having A minus 4. If you now look at the reaction very well, you discover that element helium is being added, because if you add the atomic number of helium and the atomic number of element Y, you are going to get the atomic number of X. If you also add the mass number of helium, which is 4, and the mass number of element Y, which is A minus 4, you are going to get the mass number of element X. Let's look at another example. We have radium with atomic number 88 and mass number 226. When this element is being bombarded with alpha particle, it produces another element called radon. And in this case, the atomic number of radon is 86 and the mass number of radon is 222. At this point, who can tell us the difference between the atomic number of radium and the atomic number of radon? Yes, very good. Because the atomic number of radon is 86, while that of radium is 88. Because radium has been bombarded by the alpha particle, and as a result, the atomic number of radon from radium will be reduced by 2. Thank you. And the mass number will be reduced by 4. And at the same time, if you look at the reaction, you see that the element helium is being added to make it a complete reaction. Are you following? Okay. Let's move to beta particle. The emission of beta particle makes no difference to the atomic number of a nucleus, but changes the charge carried by the nucleus and causes the atomic number to advance or increase by 1 unit. What are we talking about here? A beta particle has one charge, that is -1. So the atomic number of the new element will be increased by 1, while the mass number has no difference. So what are the properties of beta particles? 1. Their electrons are negatively charged. 2. They can be stopped by aluminum plates. 3. They can be deflected by a powerful magnetic field. 4. They have lower ionization energy compared to alpha particles. And 5. They have higher penetrating powers. Hope I am communicating. Okay, let's now look at some examples under beta particles. Let's look at the example we used the other time, element X with atomic number Z and mass number A. When element X is being bombarded with beta particle, it will also produce element Y. But in this case, the atomic number of element Y will be increased by 1, but the mass number remains the same. And with the addition of electron, that is, electron with mass number 0 and atomic number -1. So if you add the -1 with the atomic number of Y, you are going to get the atomic number of element X. Let's look at another example, thorium with atomic number 90 and mass number 234. When thorium is being bombarded with beta particle, it will produce another element that is called protactinium. And protactinium is having atomic number 91, mass number 234. If you now add this and that of electron with -1, you are going to get the atomic number of original element, which is thorium, 90. Also, if you look at the next example, sodium with atomic number 11, a mass number 24, be bombarded with beta particle to produce magnesium, atomic number 12 and mass number 24. So if you add 12 and -1 together, you are going to get what? 11. And if you add 0 and 24, what do you get? You get 24. Very good. Now we move to the last one, the last radioactive emission, gamma ray. Gamma radiation is simply loss of energy by the nucleus of a radioactive substance, while the mass and atomic numbers of such substance do not change. Because gamma ray has no charge, it has no atomic number, it has no mass number. It is neutron. It is neutral. So in this case, we look at the properties of gamma particles or gamma rays. 1. They are electromagnetic in nature. They are neither positive nor negative. They require no material medium. They have no charge like that of beta particles and alpha particle. So gamma ray is neutral. It has no charge. They have negligible ionization energy. They have the highest penetrating power, and they are not deflected by electric field. So if you look at the example under gamma ray, we have hydrogen. Hydrogen with mass number 1, atomic number 1, is being added to another element D, mass number 2, atomic number 1, to produce helium. Helium with atomic number 2 and mass number 3, with the release of energy represented by the gamma ray. So that is what we have for today. Hope it is clear to everyone. Or do you have any question? Okay. If there is no question, so we shall meet in the next class. Thank you.